Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Today our guest is Michael Crimmins, Extension Specialist and Professor of Environmental Science and of Geography. His research focuses on climate and natural resources management, and he's especially interested in climate extremes such as droughts and floods, and how we can simultaneously minimize them and adapt to them. Mike, thanks for joining us today.
Thanks for having me.
So tell us about what led to your interest in climate and weather. You live in a part of the country that has extremes, but you didn't grow up here.
I didn't.
What got your interest?
So I'm from Michigan, and I grew up in the thumb of Michigan. So if anybody knows how to look at a Michigan map, the thumb is on the eastern side of the state. Grew up pretty close to Lake Huron, and we were impacted by lake effect snowstorms quite a bit. And so I remember vividly being about 5 years old and having a snowstorm overnight and realizing that it canceled school. And so there was a mechanism out there to actually cancel school. And so that's what drew me into weather. And so from then on, I was fascinated by thunderstorms, lightning, lake effect snowstorms. And my parents tried to get me to go into engineering, but I didn't relent, and I went into atmospheric science when I was an undergrad. I've been in the Southwest for about 20 years, and I studied here at University of Arizona. And so the monsoons really caught my attention because it's such an interesting weather phenomenon. It's not quite the way you'd see it in India, where you'd have this extreme reversal in wind direction. What we have here is in the springtime, everybody knows it gets hot here. The wind is really gusty out of the southwest. As we move into June and into July, there's this real subtle change in the wind direction, the mid to upper levels of the atmosphere from the southwest to the south to the southeast. And that subtle change in wind, which is indeed a monsoon, actually introduces tropical moisture into the southwest.
So with climate change, what do you predict?
Well, it's, climate change is the most reliable signal we have, and we're seeing it. We saw it earlier this summer. The trend in temperatures are driving every season as being warmer. Precip variability in the Southwest is really complicated, and it varies from season to season. Our wintertime is driven by lots of different kinds of variability than the monsoon. We're staring down an actually really strong El Nino event coming up this coming winter. That could actually drive us to very, very wet conditions like we've seen historically across the Southwest. The monsoon isn't quite strongly connected to that same kind of variability. So we have this really interesting pattern where we can have dry winter, wet summer, dry winter. Sometimes they're both dry, sometimes they're both wet, and it's really hard to sort of predict over time. So I expect it'll get warmer here, but that crazy variability that the Southwest has, I expect will continue, maybe even get a little bit more extreme.
And might that change also involve a broader area of the U.S. than currently is affected by monsoons?
Yeah, that's a good question. It doesn't appear that you're going to see any sort of expansion or shrinking of the monsoon, because it's a subtle feature that's driven by land surface heating with the arrangement of the mountains in the southwest and down through Mexico. And so those features aren't going to change into the future. So it's going to be the overlying wind patterns and weather patterns. So the amount of moisture, how the overlying circulation patterns sort of reorganize with climate change. They look fairly subtle right now in the summertime. So again, we're not real clear of what direction we're heading in. Our rain gauge networks really aren't up to the task to be able to capture the extremes that we already see historically in the monsoon.
And is that spottiness characteristic of monsoons? You can get stuck in a part of town where you wouldn't drive because you can't see 2 feet in front of you, and yet you can be on the phone with someone a mile or two away who didn't even know it was raining.
Right. Absolutely. Yes. Absolutely characteristic of the monsoon. Our storms end up, especially in summers like this, where the moisture isn't quite there. The overriding pattern isn't quite there. And so the storms end up being very disorganized, very small in nature. And you can go out on your back porch and look across town and see little rain shafts. And, sometimes they're very destructive and damaging, but you also are a little bit jealous that you're not underneath one of those rain shafts getting that real good dousing of rain.
This has been absolutely fascinating. You live in a part of the country that gives you a livelihood, in fact, in a way that very few of the rest of us do.
I know. I'm so excited to get paid for watching the weather because it was something I did for free as a kid, for sure.
Well, thanks very much. Dr. Mike Crimmins is an expert in the complex science of climate and weather and how we can adapt maybe to make the most of our changing climate. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.